I'm going to talk about the ECW130, or what we now call it, the Cloud5 4x4 AP. So I'm going to talk a bit about the features. I will show the pictures for the housing, the mount, well, at least how it is mounted. Not so much as application scenarios, but more in general. I will also talk about the choices when still to choose the for Wi-Fi 5 or Wi-Fi 6, because this is a Wi-Fi 5 device. Some new cloud features and some other things. So first, somebody decided that we had a Wi-Fi 5 device, 4x4 device that we could bring out as an alternative to 2x2 on AX, maybe at a slightly nicer price point compared to our 4x4 Wi-Fi 6 device, the ECW230. So it's slightly slower than our 230, but otherwise it's very comparable. We think this device, just like the 230, can use in somewhat high density environments in Soho, in hospitality, or even in retail store environments. So within our list of ECWs, I think I'm missing the ECW120 in this list, but anyway, I try to compare it a little bit with the other devices, and what you can see is that if you compare it to the ECW230, it is just about being a little bit slower, about 2/3 the speed of the of the 230. But those are the maximums. I will discuss this a little bit later. So still, technically, from a technical perspective, I will still suggest everybody that our security AP, the 230S 4x4 AP, is the best that you can buy at the moment, if you're not going for the 336 with 6 GHz it is. If that's too steep, you can go for your 230 or your other 220S, the security model, depending on the use case, or you can go for even a step lower for the 220 or the ECW130, again depending on the use case. And if that's still too costly, then go down to the EC120. Commercially, of course, the order may be different, but this would be my technically order. So I will try to discuss a little bit about why 4x4 over 2x2, and also why Wi-Fi 6 over Wi-Fi 5. So let's start with some theory talk about Wi-Fi 5 and 6. So if we're talking about 2x2 or 4x4, we are talking about radio chains. And yeah, if you need 2x2, you need 2 radio chains. For 3x3, you need 3 radio chains, so 3 radios. And for 4x4, you need 4 radio chains. What happens is that although we cannot use Wi-Fi at the same time for multiple things, at least the frequency can only use it once. We can make abuse something which is called a spread diversity, because the antennas are spread from another. If we send out from one antenna and we send out a different signal for an antenna which is at a little distance, the higher distance the better actually. Then on the other side, you have multiple antennas, the same number of antennas or more. we can distinguish between the different antennas signals just by using a lot of math, just making a lot of calculations. So this wasn't possible in the early days because our chips were simply not fast enough to make all the calculations, but now we can. So if you have a 2x2 AP, you can support 2x2 clients, or you can support two Wi-Fi 5 or Wi-Fi 6 1x1 clients. I made a typo here, so it's either 1 2x2 or 2 1x1 clients. If it's a Wi-Fi 4 or earlier, then you cannot use this MIMO thing, but because those clients are not able to distinguish between the signals sent to the other client. But anyway, for both Wi-Fi 5 and 6, on Wi-Fi 5 they can use multiple MIMO, and what you can see is that if you have a 4x4, you might even be able to support up to 4 Wi-Fi 5 or 6 clients at the same time. It is very important to note out that the different clients, they need to be spread out from another. If they are really on top of each other, then they will see the same signals and they cannot distinguish from another. But if they are somewhat separate from another, then they can see the different signals and distinguish between the one and the other signal. Or rather, the AP can send the signal out in such a manner that it will be very weak for one client and very strong for the other client, and the other signal for the other client will be in reverse, so that they will hear the signal that is intended to them. And the more radio chains the AP has, the more 1x1 clients it can support, or in between it can support 2x2 clients. Again, what I said, if you have Wi-Fi 4 or older clients, then you cannot do multi-user, but we are seeing more and more Wi-Fi 5, Wi-Fi 6, and in future even Wi-Fi 7 clients coming in. So over time, this will improve, regardless if you have Wi-Fi 5 or Wi-Fi 6, or later Wi-Fi 7. So the next thing that we need to talk about has to do with speed. What kind of channel plan do you want? If you have a lot of APs, then and you need to have a channel plan, then you usually go for 20 megahertz on the 2.4 gigahertz band, and 40 or maybe even just 20 on the 5 gigahertz band. Because if you make them wider, you will have overlap between your channels and they will start to interfere, and you cannot create a good channel plan. So to sort of add it all up, I will talk about this a little bit further, but if you compare Wi-Fi 5 to Wi-Fi 6, you can do more a better modulation with Wi-Fi AX, but as I will show a little bit further on, this will only work at a short distance. So this is nice, but for most clients it will probably not be a benefit. This will be more of a benefit, and that is that the data rate on AX can be slightly higher than what you have on the on Wi-Fi 5. Again, here we're talking about lots of high speeds, but you have to note that this is for 8x8 to 8x8. This is not about 4x4 or 2x2. So these nice high speeds, maybe they're in the lab, but they're not in the actual world. Then the other thing is that for multi-user MIMO, if you are using a Wi-Fi 5, then it is only in one direction. It's only from the AP to the client. It's not from the client to the APs. So you need Wi-Fi 6 to have it in both directions. That said, depending on the application, often you will have more traffic coming from the APs to the clients, like they're going to browse web pages, then they will send up. This might be depending on the use case, because in some cases people will make lots of photos and try to share them on the internet, and then of course you might have more uplink than downlink actually. But this is for both situations. You will want something like this in a high density environment to support as many clients as possible, as quick as possible. So why would you use Wi-Fi 5? You would use Wi-Fi 5 because it is better than Wi-Fi 4. And it will allow 80 megahertz bandwidth, but although it allows this, you will probably just use 20 or 40 anyway, and it supports multi-user downlink. But again, that needs to be supported by the client, so any Wi-Fi 4 or earlier client will not support this. So the other thing is, why would you use Wi-Fi 6? Well, you would use Wi-Fi 6 for all these nice features, and to put it in text, it will allow more MSS indexes than what you had previously with Wi-Fi 5, and yeah, more bandwidth again, but still probably for a channel plan we will still just use 20 and 40. So it's nice to have, but you will probably not use it. And it will also support multi-user MIMO in the uplink direction. But again, this will only work if the clients themselves are also Wi-Fi 6. And for Wi-Fi 6 clients, it can even send out packets to clients at the same time. So these two things are a little bit different: the multi-user MIMO uplink and or multi-user MIMO in general for Wi-Fi 6, and the OFDMA. The multi-user MIMO here is about how the AP modulates the signal, so that some clients can hear the signal for one signal for them and not hear the signals as intended for other clients. So the AP is doing something very interesting with the Wi-Fi signal to send it to different clients at the same time, where only one of the clients is hearing one of the signals, the signal intended for them. And with the OFDMA, it's different. In this case, it's the same signal, but the packets are split up in parts which are sent to the different, which are intended for the different clients. So they all hear the same, receive the same packets, they hear the same things, but they only take out the part that is intended for them. But still, here again, it needs to be supported by the clients. So the OFDMA is only supported by Wi-Fi 6 clients. Now about the part with the signal strength. So the MCS things, those are have to do with amount of bits that can be sent by each pulse from the AP. And if your signal to noise ratio is better, then you might send more bits faster, everything faster than when you have less signal to noise ratio. So the worse your SNR is, the slower your throughput will be. And this is a function of two things. It's a function about how noisy your environment is, but even more importantly, it's a function of the distance. So the farther you get away, the less SNR you have. So this is when MCS 0 is something that you will have when you are very far away from the access point, very weak signal. But if you come closer, then it will be then you can speed up. So at a certain point, for Wi-Fi 5, you cannot speed up anymore, even if you get closer. But for Wi-Fi 6, if you get even closer, you might speed up even more. That said, probably if you're at this level of signal, you are within 2-3 meters from the access point. So if you're even closer than a few meters from the access points, and nobody is sitting directly on top of his AP. So from this to there, you need to be really close. So although this is nice for a normal client to AP situation where you're somewhere in a room, you will probably not go any faster than MCS 9 anyway, even though the APs would be capable of doing so. Now, the next question would be why not wait? Why wait or not wait for Wi-Fi 6? That's because although we get even more speed and more MIMO antennas, well, I don't think we have ever seen an 8x8 yet, although it's possible. And even the 4x4s are not that many. It is nice. All these features are very nice, but especially in a high density environment, it is not likely that it will bring us much. And most importantly, of course, it's not here that. So if you need a solution now, if you need something for a customer now, then you need to go with either Wi-Fi 6 or Wi-Fi 5, depending on the what there is. We do expect Wi-Fi 7 to appear this year, but it will be at a cost. So anybody have any questions so far before I move on to the latest features that we have in our cloud? Okay, not seeing any questions, so I'm moving on. So one feature that we have recently added is Active Directory multi-group support. So we already supported Active Directory, that you could connect our APs or have our APs check with a Active Directory server if they are allowed to connect to the network based on the Microsoft credentials. But now we can even add something else. We can add group names. So you can for instance, in a teaching environment, you can separate the teachers from the students. And the staff to different things. I think that's a very, there are some limitations. We have maximum of 2 Active Directory servers and 3 groups that you can configure, but in any case, it is pretty nice to have at the moment. And then next, there's a feature. I will discuss the intended use, but I'm even more interested in how you can also use it. So let me move on. this is about Wi-Fi calling, which is a Cloud AP Pro license feature, just like Active Directory is, by the way. So Wi-Fi calling is for something that has to do with mobile operators. So one of the challenges for mobile operators is providing mobile phone coverage. And in some places, because you're deep inside a very big building, or maybe because you're in the countryside, the cell phone coverage will not be as good as that you would hope. This can be an issue in any type of environment. This can be an issue inside the schools or homes when they're in the countryside, whatever. But one way to add coverage is making use of existing Wi-Fi to connect to the internet and route all the calls over Wi-Fi back to the mobile operator, their core network. This feature has been standardized and is supported by modern Android and Apple phone OSs already. So I put in some verticals, the malls, the homes. If yeah, in this case, even for the operators, of course. The big public service education. So all of these environments, this could make sense to do. But before we discuss this, I need to go a little bit back in the past. I need to discuss something that we call voice over LTE. Voice over LTE or voice over IP over long-term evolution from, or what we call mobile 4G. This is what we use as a base. Wi-Fi calling is an extension of this. So voice over LTE became a thing because at first, when we had a smartphone, you could either do your call or you could do data. You could not do both at the same time. To solve this, what the operators did is they made some changes that instead of doing your voice calls like before, they routed the voice call over data so that regardless of what you are doing, you could take a call because it's what's running over data. Actually, I voice over IP call at the same time as doing other stuff with your smartphone, like looking at YouTube or checking some web pages, which has something to do with your call. So usually it's subscription based, but I think that at the moment it's some sort of a default thing that all our telco providers provide. So when you're able to make calls and also browse your internet at the same time on your smartphone, you are probably making use of voice over LTE. So that brings us to Wi-Fi calling, or what's also known as for voice over Wi-Fi. This makes it possible to roam between the your mobile operator, its antennas to the Wi-Fi that's over there. And you can actually roam from the one to the other without losing your connection. Although you may experience some a short period that you have loss of some little bit of voice. So this can roam between Wi-Fi and LTE, and it can roam between Wi-Fi and access points. Additionally, if you have this, and you can use this from another country by just having this enabled, you might even be able to avoid international roaming fees. That said, I know that some of the operators only allow this from their own broadband network, so nothing international, and others do not allow it internationally because they make more money if they force you to make the calls over the normal network. That said, if you use a VPN service, you might be able to work around both of this, but that might impact your quality. So how does it work? You need to have a subscription to a mobile operator who supports Wi-Fi calling, and then you just enable the function Wi-Fi calling on your mobile on your smartphone. And when you make the call, the smartphone will search for the gateway for this, and then it will build an IPsec tunnel for the voice over IP data transfer, so that even if it goes over an untrusted Wi-Fi network and the very untrusted internet, it will be safe. This is something that's very important to the mobile operators, of course. Each mobile operator has their own servers for this, and the server will talk to the internal authorization servers of the operator to check if the number is correct and stuff like that. And then as soon as that's all okay, it will just pass the packets and allow you to make the call. So for the access point to optimally support this, you want the access point to have low latency and good bandwidth for this application. And for this, we need to ensure that Wi-Fi calling traffic has the highest priority. So the Wi-Fi calling QoS, its magic, prioritizes Wi-Fi calling traffic to the configured gateway servers of the mobile operator. That said, it is important to note that even if you do not have this enabled in your APs, it will still work. This is about improving the quality to the best it could be. And especially in lightly loaded environments, you will probably not even notice that you have not done anything special. It should work perfectly fine. This is especially important when it's a very busy Wi-Fi network. So the magic of this is based on the IPs of the gateways configured. So we need to configure the fully qualified domain names of the servers, of the mobile servers, and it does not, and then it checks the IP address and uses that IP address. It does not do anything with the packet format or content itself. It just prioritizes based on the IPs. And when it sees the packets, then it will prioritize the packets, and so those packets coming from or going to those gateway IPs will have a more higher priority than the other ones. And you can set the priority in our cloud UI. So at first I was not even aware this feature was already a thing, but I looked a little bit around and I found that in most countries, probably all of the countries in Europe at the moment, Wi-Fi calling is supported. These are just the ones that I looked for and found. So we have it in the Netherlands, in Denmark, in Finland, Sweden, Switzerland, the UK, and probably also in the other things. The funny thing is that whilst we call it Wi-Fi calling in English, in most cases when you look at the naming for in the different countries, it is just the exact translation from it. So you just translate calling to the local language, and that's how it's called. So the configuration is itself is not hard. You just enable it and you add the mobile operators is gateway, but the hard part is finding the name that you need to add here, or the IP address. So for the QoS priority, by default is voice, and you can leave it at that for this application. And we can add up to 100 different fully qualified domain names or IP addresses. The only requirement that we do have in this case is that the firmware version of the APs needs to be version 1 something 50 or higher, which it already is at the moment in, I think, all our APs. So all our APs should support this now. I checked on my own phone. You just go to settings, network, internet, call and SMS, Wi-Fi calling, enable Wi-Fi calling, open calling preferences, and then select what you want to have. So this is pretty easy to configure, and it's already in your Android phones and your Apple iPhones. So when I heard of this, the first thing I thought of is how can I use this feature for prioritizing normal voice over IP? And the answer to that is yes. I can just put in the IP address of my own voice over IP gateway and use that. That said, it's not even limited to just voice over IP, because the whole system just looks at the IPs. It does not look at the type of traffic. So if you need to expedite any type of traffic, think of something like terminal server traffic. If for some reason you think that you need to expedite YouTube, you could even do that. I wouldn't, because it's probably better that the YouTube algorithm lower the throughput, but you could use this for anything. You can use it for VoIP, your own VoIP, to your own voice over IP provider, or to your own voice over IP server, but you can use it for any servers. Just put in the IP addresses and the fully qualified domain names. Just remember that it doesn't make sense to prioritize everything, because in the end, then all the traffic will be the same again. So this is really about prioritizing a small portion of your traffic and making sure that if there is not enough room for all the traffic, that at least that part of the traffic goes through. Any questions? So if you think of any questions at a later time about the topics in this webinar, just send us an email. If you have any suggestions for subjects for new topics, just send us a email, all to support@engeniusnetworks.eu. If you have any sales questions, send an email to your sales contact, or go to our website and the contact us page for more information. Oh wait, I will try again. Okay, for some reason at the moment my system, after I uploaded the uploaded the data sheets, it does not allow me to upload the PDF. I will send the PDF at a later time. Alessandro, my colleague, is telling me that WiFi Calling appears to be available with at least one Italian operator from this week. So my timing about this topic is perfect for Italy. I will make sure that the PDF of the presentation is sent out after the webinar. Yes, but you about the Wi-Fi calling, I hope that is clear to you that it's not just I'm not just excited about the Wi-Fi calling itself. That is very nice, but I'm even more excited how I can use it to expedite other types of traffic, just in case that I need that to happen. Because before it was very hard, or well, actually impossible to do that. Okay, I think that I handled all the questions, and I want to thank everybody for their for being here. Next week, I will also do a webinar, and Alessandro will do another webinar, I think. In any case, I will do a Dutch speaking webinar about the security gateways. Okay, everybody, thank you very much. Have a nice day, and until the next time.